And then to give you an idea of what folks are building with this in the real world, we're going to pass things over to Eric Capuano, one of the founders of the Digital Defense Institute, who is going to show us what he's been building against LimaCharlie's MCP server. Over to you, Eric.
Hey, Chris, thanks so much for inviting me. Pretty exciting topic, actually. It's something I've been spending a fair amount of time with here recently because it's evident to me that the way that LLMs are just exponentially improving. Obviously, still not perfect, but you can see the progress that the big organizations behind them are making in making these tools better and faster and smarter. But where it really gets interesting is when you can couple them with an MCP like LimaCharlie's, because now I have the capabilities of the LLM, which I can fine tune and tweak to my specific use case. I can now directly interface with platforms that do important things, right? So what I wanted to show you all today is kind of a proof of concept I have of leveraging Claude Code as a chat interface for directly interfacing with LimaCharlie. But I've taken it a few steps further because one of the cool things I like about Claude Code is I can heavily customize its behavior, right? So Claude Code will read in, instruction files that you provide it. And by default, it will always read in this claude.md here in the root directory that you launch it from. So you can kind of use that as a starting point, right? I can say, okay, so my basic Claude instructions that I always want followed in this repository are effectively it's a markdown file full of specific instructions, ways that I want it to behave, ways I want it to do things. And it's great because I can actually create sort of like a hierarchy of instructions. So I have additional files being read in a subdirectory here that have more specific functions, right? Like where I have many different LSQL examples defined. I even have a whole collection of sample events so that it kind of understands what LimaCharlie events generally look like, so that when it's preparing an LSQL query or something else that requires that knowledge, it can call upon those sample events that I provided to be more accurate in building its outputs. So that's super helpful because now Claude isn't just using its general training to do the tasks. It's actually using effectively system prompts that I've given it that give it more expertise, more context around what it is I'm trying to accomplish here. So as you kind of see in my directory structure here, I've got various other items like, for instance, corpus of detection rules that I want it to be able to reference, sets of instructions. I even keep, for instance, a chat archive. So as I'm using Claude to perform, say, a triage investigation, we're constantly tuning and tweaking as we go. If I recognize through its workflow that it didn't necessarily do the thing I wanted it to do, well, one, I take that as an opportunity to go improve my Claude MD files. But let's say an investigation goes incredibly smoothly. Claude did all the things that I wanted it to do, and I thought that the outcome was a very good outcome. Well, then I'll export that conversation into my chat archive to kind of use that as another reference point for Claude to say, hey, these are investigations that went really well. So you can sort of go back and replay them and understand what the most effective steps were in that investigation. So let's go ahead and just jump in and give it a try, right? Now, keep in mind, this is live, right? I didn't pre-script this or anything. So it's only going to be as good as it can based on all the instructions I've provided it and just, the general variables that may occur here. But let's give it a try. So I'm going to go ahead and execute Claude here in this working directory. And I can kind of confirm that it has read in my instruction files by hitting /status. And so I can see here that it has my personal Claude MD, which is in my home directory on my MacBook here, which is just kind of like universal instructions that I want Claude to follow. But then it has also recognized that this project has its own Claude MD and even nested instructions that are imported within it. So I can confirm, okay, great. It has my instructions, right? It knows the things that I need it to know so that we can, get some good work done here. Now, another thing that I absolutely have to, keep in mind is I need to link Claude to the LimaCharlie MCP, which I've previously done. And I can validate that that is correct and that, we're properly connected by running /MCP and seeing LimaCharlie here saying that it is connected. And if I even expand on that, I can just get some additional information like there's my URL for the LimaCharlie MCP, the specific config file that contains credentials and all that good stuff, and then even the list of tools. And I kind of like that because it gives me the idea of, oh, well, let's see, what all can this MCP do, right? So I can kind of explore all the exposed functions that the MCP provides. But see, Claude Code already has that context now. It has already read in all of those tools and their usage. So it kind of understands what's capable, what's possible, what specific arguments need to be provided when you call one of these tools. So that's good. We're ready to go. Let's go ahead and start with, for instance, a typical workflow. Let's ask Claude to go and get recent detections out of LimaCharlie. Let's get all recent detections in LimaCharlie worthwhile of investigation. So what it's going to do is it's going to reference what LimaCharlie MCP tools help it gather this information. Now you see, because I've informed it that LimaCharlie speaks in UTC timestamps. So it knows that before it can make that call, it needs to get right now's time in UTC. So that was the first thing it did. Now it's pulling historic detections from the org that I'm connected to. So it says, hey, we found 10 high priority detections related to suspicious run DLL 32 activity on 2 different Windows systems. It says this is a critical investigation. Let's kind of see what it's doing. So it's built itself a checklist of things it's going to do. Let's make sure those sensors are online so that we can actually kind of dive into them and get more information. But it's saying already, based on what it knows, that it suspects Cobalt Strike might be involved. And I'm guessing that it's worked that out simply because Run DLL 32 here is exhibiting the types of things that are commonly associated with Cobalt Strike. But okay, it's an interesting theory, but let's see how well it validates its theory there. So it's saying here, potential Cobalt Strike, it's saying, you know, this system here has Run DLL 32, making network connections to this external IP. And so does this one here. So we got these 2 systems both. And it also correctly calls out that the reason Run DLL 32 is suspicious, in addition to the fact that it's making outbound network connections, is that the command line arguments are sort of invalid, because generally you would expect to see a DLL in the command line arguments for Run DLL 32. And it appears that these do not have that, which it properly recognized as classic Cobalt Strike behavior. So, okay, it's working out those network connections and understanding that that IP address is actually owned by Google Cloud. So if this is actual attacker infrastructure, then it must be hosted maybe in GCP. Run DLL 32 is running a system, which I would say is pretty unusual, you know, and that could be indicative of a privilege escalation. So I would agree with its findings so far. Continued on, it's doing some additional things according to its own checklist, checking that that sensor is online. Both of them appear to be. It's getting some OS version information from each system, maybe to work out, you know, what the operating system versions are. So we've got Server 2022 and Windows 10 Pro. And now it looks like it's digging deeper into the Run DLL 32 processes themselves. So it's crafting its own LCQL, right? And it's trying to dive in deeper to maybe work out, hey, give me all new process and existing process events containing Run DLL 32 where there's no DLL in the command line arguments, right? And you notice it's going through a few iterations here of various different LCQL queries. And then it also went ahead and just enumerated all the running processes on one of these sensors, where it's actually able to confirm beyond what just historical data says. It's saying, no, according to the right now state of that system, that PID is still running on this machine. So it has now decided to search for Cobalt Strike indicators specifically in memory, since that process ID is still active. Okay, so it kicked off a find strings against that process ID 3788. That's a pretty targeted approach. I like that. And it looks like it's searching for some of the most common strings that you're likely to find in a poorly customized Cobalt Strike beacon payload, like reflective loader. It's definitely a good one. As well as, you know, some of the other common, these look like some of the default SMB named pipes that may be present in a beacon, you know, so some pretty solid strings here. Oh, okay, but it looks like it hit some kind of timeout on that command. I'm curious how it navigated that. So next, it ran get process modules. That's a pretty smart move because now it's going to say, show me all the DLLs, loaded by this 3788. And this is pretty cool because it was able to work out from all those loaded modules that the run DLL32 process had wininet.dll loaded, which many folks might be aware that wininet is one of the most common DLLs that you see loaded when a process needs the ability to communicate across networks, specifically across the internet, because it gives it the ability to make HTTP connections. So if we're trying to, run down a theory of this being a possible C2 beacon, the presence of wininet DLL is a pretty strong indicator that it may very well be just that. So, okay, it's continuing on with some additional LCQL queries here. Looks like it ran this query here, looking at network connections for run DL32 over the last 30 minutes. For one reason or another, it doesn't look like it found any hits. So it extended the time range. And looks like it just went back an hour instead of only 30 minutes. And this time it did have results. So you can see here, there were obviously many lines returned from that query. And with those results, it looks like it was able to work out that it does in fact look like beaconing behavior because it saw many connections to the same C2 server. Okay, that's good, good data point. But now it's going to look for how the process came to be in the first place. What launched it, right? So, and that's obviously an excellent investigative question because run DLL32 didn't just magically start running. Something had to have launched it, which may be the thread we'd have to pull on in order to work out possible persistence mechanisms. Okay, so it ran a query to try to identify maybe parent process information. So it's looking for new processes where the PID is 3788 or the PID is 2680, which I'm guessing is the parent process ID that it identified for run DLL32. All right, looks like it's got to keep going though. Maybe it's refining its information here. So it's just refocusing its query. Okay, so it's saying the malicious run DLL32 was not captured in process creation events. It's interesting. So it's looking for signs of process injection or child processes. All right, doesn't look like it came up with anything substantial with that query. And it's going to now pivot and look at the second system. So on the second system, it's now working out the details around run DLL32. And looks like it's probably working out. It's got very common similarities between the two systems. So it may be shortcutting here now to kind of a summary of its findings. Maybe it's got pretty high confidence. So let's see what it has to say here in the summary. It's saying, yes, this is the critical security incident because it's confident that this is a Cobalt Strike compromise because it has confirmed the beacon on two systems with the C2 server of this IP and that port. It has given me the process ID of each infected process and some key indicators of compromise, being the run DLL32 with the absent expected command line arguments, the presence of wininet DLL loaded in each of those processes. It's running a system. It appears to be performing regular beaconing to a possible C2 server. And, it's giving me kind of a time frame of when that process creation came to be. And just kind of confirming that, hey, look, it looks like, interestingly, run DLL32 was launched approximately at the same time on both of these systems, which is noteworthy. And then sort of the period of time it observed some of this beaconing activity and even how many connections it saw in that period of time. So it's very aggressively recommending it's time to isolate these systems. Right? So it's prepared, but it is not authorized to fire off the isolate network command on those sensors. Now, this is a really important thing to call out, right? So as I'm working with Claude Code over time, I'm able to kind of give it instructions over which commands is it authorized to go ahead and run automatically, which is, by the way, why this investigation just kind of ran away, because I've authorized it to run safe commands like running LCQL queries or just enumerating data about endpoints, because these are all generally safe commands. The worst thing that's going to happen is it sends a bad query, or it sends a query that brings back too much data, which it will do from time to time, and it's pretty good at kind of recovering from those types of situations. But what I do not authorize it to do without my intervention is something that's going to make an impact, right? Like isolating a system, right? So I love that kind of flexibility and that customization, and you can really make it yours, right? You can really get really specific about the permissions that it has and what it's able to do on its own. But what I think is really neat about this is 100% accurate, by the way. This investigation summary is 100% what's happening on those two systems. This is a lab environment, so I have the insights of knowing what's really going on. And it is, in fact, Cobalt Strike beacons on both of those machines running inside of Run DLL32. Now, obviously, there's still room for improvement here. This is a very early proof of concept. But what's really cool is as I go through these iterations, I'm going to go ahead and tell it, no, do not isolate these systems. As I go through these iterations, I can just simply provide it additional context. Like, we absolutely, want to be sure that we identify persistence, use all available MCP tools to perform a thorough investigation around possible persistence, right? And what I can do to kind of immortalize that guidance is say, please update my Claude instruction files with this guidance, right? That way, it's not just going to help it right now in this one investigation, but it's going to take note of that in its permanent instruction set so that all future investigations take that into account, right? So again, what I like about it is, of course, if you just fire it up out of the blue, it's going to be so-so. And actually, I will admit, it's not bad. With no prior instructions, with no additional context, it is actually not terrible. It's pretty decent, but it only gets better and better and better as you provide those insights, right? As you give it that investigative sort of context on, where it needs to double down its focus, and even sometimes where it need not go, right? Sometimes it veers off into strange, areas in its flow, and that's to be expected. But that's why, again, as you infuse it with your knowledge, your expertise, your experience of efficient and effective investigations, it factors that in, so it does get better and smarter the more that you use it. So anyway, hope that was interesting and, super exciting stuff. And, huge thanks to the team at LimaCharlie for building and exposing this MCP, and especially providing some really cutting edge capabilities. Like, for instance, one of the MCP tools I think is quite impressive, and I want other folks to know about it, is the ability to generate LCQL queries from plain text language or even detection rules. And I just think that that's fascinating because, being honest, LCQL is not the easiest thing sometimes to wrap your head around. And so the fact that I can call this tool right here and say, hey, I want an LCQL query that'll go and find processes in the last 24 hours that exhibit signs of X. I can just give it that instruction. And Claude doesn't have to figure out the LCQL. It'll call that MCP tool, and that MCP tool will work it out and give Claude the ideal LCQL query to run. And, again, I could do the same thing. Say, hey, turn this activity into a DNR rule, and it's able to do that. And so really impressive capabilities here. And I am excited to kind of see where it goes as it evolves and gets smarter and more mature. So, all right. Thanks so much for having me on, Chris. And back to you.
Eric, thank you so much for being with us here today. And before we wrap things up, I'm curious, Maxim, where do you see this going, and how does our approach ensure we're going to be able to keep up with this technology?
That's a good question. Fundamentally, who knows, right? It's kind of the unsatisfying question, meaning things move so fast that I think the best thing that we are doing, the thing that will ensure that we kind of are able to stay at the edge there, is by taking an approach that is where we are not over indexing on very complex things today, right? We try to make the integration into the latest technologies really, really easy and kind of like at the infrastructure level, which sounds, it sounds daunting, but it really isn't. All it really means is that, we want to use the best technologies like MCP that, just come out and be able to leverage those. And because we're taking this unopinionated and cloud platform kind of approach, it means that it's easy for us to do that. The other part of it is the thing that we really want to provide for folks is a great environment for them to bring in their own AI or to build really their AI capabilities within the platform, right? To add their own. That's where the AI agent kind of like comes in. Is we don't want people to be forced to go and stand up all of these other big pieces of infrastructure. We want people to be able to, using a prompt, automate a huge part of their job, really just simplify the scaling that they have to do, right? Because especially if I keep coming back to it, but especially if you're a service provider and you have 5,000 customers, this one product that has one web console that works great for enterprise is a non-starter for you. But now if you start to look at it from the perspective of like, I have infrastructure as code, my prompts are propagated through infra as code, and all of my agents can operate, with variables and like all of that. Now you're really starting to automate. And if you're a service provider, that's life and death.
Awesome. So that brings us to the end of today's session. We've covered a lot of ground, from our foundational philosophy to real-world AI integrations and the tools we're giving security teams to stay in control as this technology continues to evolve. Whether it's our support bot, the rule building assistant, native LLM playbooks, or the secure and powerful MCP server, our goal remains the same: to give you the flexibility to build your security operations your way. If you want to dive deeper, test things out, or just start experimenting with AI in your own workflow, everything we've shown you today is accessible on our free tier, which you can access at LimaCharlie.io. No credit card required. Just get in there, join our community forum, community.limacharlie.io, start talking to us. Let's make some cool stuff. We're really excited to see what you do with it. And thanks again for spending time with us. And as always, don't hesitate to reach out if you want to talk some more. Take care. Cheers.